Burger King has a patent. Not for a sauce. Not for a bun. For a rock. And that rock is the single most protected, most reverse-engineered, most obsessed over piece of technology in the entire fast food industry. That sentence sounds absurd. It sounds like something someone made up to win an argument at a barbecue. But the moment you pull on that thread, the moment you start understanding what is actually happening inside a burger. King Broiler, what those ceramic stones are doing at a molecular level, and why every single one of Burger King's biggest competitors has spent decades trying to replicate the exact same effect without triggering a lawsuit, this stops being a story about fast food. It becomes a story about the most quietly contested piece of flavor science in American culinary history. And there is a reason Burger King has never fully explained it. Because the explanation would reveal something that changes the way you think about every burger you have ever eaten. Let's go back to 1954. Burger King opens its first location in Jacksonville, Florida. The founding concept is simple, almost reckless in its ambition: serve a flame-grilled burger faster than anyone else in the world. Not pan-fried. Not steamed. Not cooked on a flat-top griddle the way McDonald's was already doing with ruthless efficiency. Flame-grilled. The founders believed, correctly, it would turn out, that fire produces something that no other cooking method can replicate. A specific chemical reaction. A specific flavor compound. Something that lives not in the seasoning, not in the patty itself, but in the moment that animal fat meets open flame and becomes something else entirely. What they were chasing, without yet having the language to describe it precisely, was the Maillard reaction combined with pyrolysis-generated smoke compounds. Two processes that happen simultaneously over an open flame and produce a flavor profile that the human brain is literally hardwired, at an evolutionary level, to find irresistible. We are drawn to the smell of food cooked over fire the way we are drawn to almost nothing else. It is not a preference. It is a biological inheritance. 400,000 years of human ancestors cooking meat over open flame have encoded that response into our neural architecture. Burger King wasn't just selling a sandwich. They were selling a primal memory. But here is the problem that almost destroyed the entire concept before it ever became a billion-dollar brand. Open flame and industrial fast food production are, by every engineering standard, violently incompatible. Picture this. You are trying to serve a flame-grilled burger in under 3 minutes, at volume, across thousands of locations, with teenage employees, no professional kitchen training, and zero tolerance for inconsistency. Open flame does not care about your operational standards. It flares when fat drips. It scorches when airflow shifts. It goes out when conditions change. It produces a brilliant, glorious, unpredictable cooking environment that is completely antithetical to the controlled, repeatable, scalable process that fast food requires. Every location needed to produce an identical burger. Every shift, every hour, every day, regardless of humidity, elevation, ambient temperature, employee experience, or the age of the equipment. And they needed to do it over fire. That tension, between the wildness of flame and the precision of industrial production, is what created the ceramic stone. And the story of how that stone came to exist is stranger than anything Burger King's marketing team has ever been willing to tell publicly. But that's not even the craziest part. The device that Burger King developed to solve this problem is called the continuous chain gas broiler. And at the heart of that broiler are ceramic briquettes, specific, engineered, proprietary ceramic stones positioned directly above the gas flame and directly below the meat. Those stones do something that an open flame alone cannot do with any consistency. They absorb the radiant heat of the flame, distribute it evenly across their surface, and re-radiate it upward into the patty in a controlled, steady, uniform thermal environment. But that is only the first function. The second function is the one that nobody talks about. When fat from the cooking beef patty drips downward and hits those superheated ceramic stones, stones that are maintaining temperatures in excess of 700 degrees Fahrenheit, that fat does not simply burn away. It vaporizes instantaneously. And as it vaporizes, it generates a specific spectrum of aromatic smoke compounds that travel immediately upward, into the meat, completing a flavor transfer that is chemically distinct from anything produced by a flat-top griddle, a gas flame alone, or even a traditional charcoal grill. The smoke is not incidental to the cooking process. The smoke is the product. The ceramic stone is not a heat distributor. It is a flavor manufacturing device. Now consider what this means from a competitive standpoint. McDonald's cannot replicate this. Wendy's cannot replicate this. Because neither of them uses a broiler system with ceramic vaporization briquettes as the central cooking mechanism. They are producing different chemical compounds in their cooking process, which means they are producing a fundamentally different flavor at a molecular level. This is not subjective preference. This is organic chemistry. And Burger King has been sitting on top of this chemical advantage since the 1950s, largely without the general public understanding what it actually is. What happened next in the industry was essentially a 70-year war fought entirely in engineering labs and patent offices. Here is a fact that the fast food industry does not advertise: between 1970 and 2010, no fewer than a dozen major food equipment manufacturers filed patents attempting to replicate the specific vaporization effect of Burger King's ceramic broiler system using alternative materials: lava rock, compressed carbon, coated metal grids, synthetic mineral composites, without infringing on the proprietary elements of the Burger King system. Some of those attempts came from manufacturers openly contracted by McDonald's and Wendy's to develop flame broiling capability. The Holy Grail was a system that could produce the same pyrolysis-driven smoke compounds as the ceramic vaporization process without triggering IP liability. The equipment industry spent 40 years and an estimated hundreds of millions of research dollars chasing a rock. Most of them failed. Not because the engineering was impossible. Because the ceramic matrix that Burger King uses isn't just a material. It's a calibrated thermal system. The specific porosity of the ceramic, the specific surface temperature it reaches, the specific rate at which fat vaporizes on contact. These variables interact with each other in a way that took years of refinement to optimize and that cannot simply be reproduced by swapping in a different material. Change the porosity and you change the vaporization rate. Change the surface temperature and you change the chemical composition of the smoke.